In lesson 4.4, we're going to solve quadratics by factoring when a doesn't equal 1. This factoring method definitely challenges you. The first thing you want to do is always check for that common factor. If there's a common factor within all three terms, you need to factor that out first before we apply this process. The second thing you want to do is, since a doesn't equal 1, we have to actually kind of configure our split the c rule a little differently. So step 2, we're going to multiply a times c. And then we factor that product to get the b value. So it's called a times c split to get b. And then from here, we take the b term and we split it into two parts based on the factoring rule that we got within steps 3 and 4. I know, this sounds so crazy just on its own. Once we split bx into two parts, we'll actually have 4 terms instead of 3. And what we'll do with that is group the first two and group the last two, and then look back at those common factors again. You should have common factors in step 7, and eventually we'll be able to write out our quadratic function that was originally in standard form into that appropriate intercept form. All right, so let's put these steps to the test over with some examples on the right. Our first example for factoring, 7x squared minus 20x minus 3. If we look at each of these coefficients, we do not have a common factor. That means we're going to go right to step 2. It says multiply a times c. So what I like to do here is actually physically circle the a coefficient and the c coefficient, and then I kind of connect them. And I multiply. Easy enough. Negative 3 times 7 is negative 21. Now we want to find factors, numbers that multiply to equal 21. We could do 1 times 21, we could do 3 times 7, or we could do 2 times 10. I guess I forgot that one. There are 3 pairs that we could work with in some way to get negative 21 as a product. But our goal is to find a pair that add to get that negative 20 in the middle. I notice that if we make 21 negative, this pair would multiply to get negative 21 and add to get negative 20. So here's where it says split that bx term into 2 parts. We're going to take negative 20x and literally split it into 1x minus 21x. And I got those numbers from the factored rule on the right-hand side. Now that 7x squared is going to go out in front. The 1x was positive, so I'm just going to write plus. And then minus 3 as the constant goes at the end. Are you okay with that step? If not, rewind it and watch it again before we move on. Our next step, step 6, group the first 2 terms together. So I'm just going to put a parenthesis around them. And then the second 2 terms together. And we look for a common factor. Now in that first parenthesis, we've got 7x squared and 1x. All they have in common is an x. I'm going to factor that out, and we would be left with 7x plus 1. And that's all you do for that step. Here's what we have to watch for in that second parenthesis. Notice the 21x is negative, so we have to factor that negative out for sure. What else could we take out of 21x and 3? Well, really, we could only take out that 3. If we take out then negative 3 out of negative 21x, we would have positive 7x left over. And if we take negative 3 out of negative 3, guess what? We would get plus 1. Your goal in this process is to have the parenthesis here and then the parenthesis on the right to be the same, like the exact same, and they are. What that means is that's one of our final parenthesis factors. So we're just going to write 7x plus 1 one time. And then we take the parts that are on the outside, the x minus 3, and oh, I forgot the 1, sorry. Back up. All right, the x and the minus 3, and you just write that as x minus 3, and that's it. That's your factored product. There's your x minus p and x minus q. Factored form for 7x squared minus 20x minus 3. Let's try another one. In example B, we have 3x squared plus 5x minus 12. We have a 3, a 5, and a negative 12. So again, there isn't a common factor in this round. What we'll do first then is take the a coefficient, that lead coefficient, times c, the constant, and multiply them. 3 times negative 12 is negative 36. Let's break this down. Lots of numbers going to 36. We've actually done this one before. We have 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Now, to get negative 36 as a product, we have to make sure that one of them is positive, one of them is negative, and then we want them to add this time to get positive 5. If we take a look at our list, it looks like we could do negative 4 plus 9, and that would give us positive 5. So those are our factors for step 4, and that's what would add, or that would be what adds up to get that 5x in the middle. Let's take that bx term and split it. We're going to do negative 4x in the first parenthesis plus 9x in that second parenthesis. And I often have students ask, does it matter if we flip them around? Not at all. You could put the 9x first and the negative 4x second, and that would be totally okay. All right, this is the way I'm going to write it, though. I'll drop that first term down out in front, 3x squared, and then notice it's minus 4x plus 9x, and then the constant minus 12. From here, put a parenthesis around the first two terms and the second two terms, and we look for that common factor. 3x squared minus 4x, we only get an x that we can factor out of both of those terms, and that leaves us with 3x and then minus 4. In the second parenthesis, let's see what happens. We've got, whoops, I didn't know I had put that there, hang on. We've got 9x minus 12. So what do both 9 and 12 have in common? Well, 3 goes into both of them, so that would be our common factor. If we take 3 out, 3 goes into 9x, we would have 3x left over, and 3 goes into 12 4 times. So remember, in this step, everybody, we want our parentheses to be the exact same, and they are. That tells us that that's one of our two factors in intercept form. And then we just take those parts on the outside. Now we have x and positive 3. We literally would just write that as x plus 3. And that would be your quadratic function converted from standard form to intercept form. For our last factoring example, 8x squared plus 38x minus 10, get this. We've got an 8, a 38, and a 10. So on this example, we do in fact have that common factor. It is essential to take that out in the very first step. What goes into both, or all three of these numbers, 8, 38, and 10? It's small, it's only a 2, but we have to put that to the outside before we do the a times c split to get the bx and all that stuff. If we factor out that 2, it makes 8x squared smaller, all the way down to 4x squared, plus 2 goes into 38x, we would have 19x left over, and then 2 goes into negative 10, negative 5. Now we have 4, 19, and 5. Nothing factors out of those three coefficients. We're ready to do a times c, split to get b. A now is 4, and c is negative 5. If we multiply those two, we get negative 20. Numbers that go into 20 are 1 and 20, 2 and 10, and 4 and 5. Now we want positive 19 in the middle. That means if I take 1 and 20, if I make 1 negative and 20 positive, we could get that plus 19 in the middle. Let's split that bx term. I'll put negative 1x first, plus 20x second, and then drop everything else down. That gives us our 4x squared beforehand, and then the minus 5 after. I'm going to leave that 2 until the very end, but we have to remember to put it in our final answer. All right, let's put parentheses around the first two terms and the last two terms, and we'll see what we have for common factors. Oftentimes, everybody, we're going to get an x for sure out of that first term, and sometimes that's all we get. There could be times we have more, but in this case, again, we're only going to have that x. If we factor out x from 4x squared, we get 4x left over. And if we factor x out of itself, we'll have minus 1. That's that first parenthesis. In the second parenthesis, we have 20x and 5. We could take a 5 out of both of those terms. 5 goes into 20x, we would have 4x left over, and then 5 goes into itself once. Again, this works out really well when we're doing this together, but if your answer has different signs, like one's a plus 1 and one's a minus 1, or the numbers aren't the exact same, you have to stop at this step and go back and look at your work. Luckily for us, this works out great, yay! That means 4x minus 1 is one of our factors, put those parentheses in there, and then take the parts that are on the outside, the x and the 5, and x plus 5 is the other factor. So what is the purpose of being able to factor when a isn't 1? Well, truly, if we're putting our quadratic function in intercept form, we're solving for x-intercepts. And when there's that a coefficient out in front, it's likely that your x-intercepts will be fractions. So being able to factor will allow us to solve for our x-intercepts in fraction form. We're going to follow the same steps that we did in 4.3. If we have a quadratic function, y equals 5x squared minus 27x minus 18, the first thing we want to do is set this equal to 0. So I'm going to eliminate the y on the left and just substitute 0 on that left-hand side. Equals 5x squared minus 27x minus 18. Let's check for common factors. 5, 27, 18. I think we miss out because of that 5, so there aren't any common factors. Let's go right to our next step then. Multiply a times c. 5 times negative 18 is negative 90. There are a lot of factors of negative 90. We could do 1 times 90. We could do 2 times 45. 3 times 30. 4 doesn't go in. We could do 5 times 18. 6 times 15. 8, 9 times 10. And those two are factors that are close enough together that there wouldn't be any others. Sometimes you really have to just guess and check, and that's where a calculator might come in handy to try to determine factors that would multiply to get that product a times c. Okay, so now let's figure out how do we get negative 27 in the middle. Looking at this list, I think if we navigate 3 and 30, if we make 3 positive and 30 negative, that would multiply to be negative 90, and they would add to get negative 27 in the middle. So there's our AC product. Now let's split that bx term into 3x minus 30x. Drop everything else down, so that's 5x squared plus 3x minus 30x minus 18. Group the first two terms and group the second two terms. 5x squared and 3x, again, all we can take out is an x, and we have 5x plus 3 left over. Negative 30x minus 18, we've got to take care of that negative for sure. 30 and 18, I know 2 goes in, 3 goes in, 6 would go in, and that's the biggest factor. So let's factor that out. 6 goes into 30, or negative 6 goes into negative 30x, we'd have positive 5x left over. And negative 6 goes into negative 18, positive 3 times. Whew, it worked. Notice our parentheses are the exact same, so that means that's one of the intercept form parentheses. And then those parts on the outside, the x and the negative 6, yep, they make that other parenthesis. Now, if we were just factoring, we could stop here. But remember the very beginning, what we did first? We set them equal to 0. Now we're going to apply the zero product property, which ultimately just means because we have two parentheses, we know we'll have two different x-intercepts. Let's set them each equal to 0 and solve. I caution you to do this in your head because a lot of times we miss a plus or a minus sign thinking we've already moved it over correctly. Show the work on this. Save yourself some points. To move that 3 over, make sure we subtract it. And then to get x completely by itself, divide by 5. X equals negative 3/5. So this means it would cross the x-axis at a fraction location, negative 3/5, somewhere between 0 and negative 1 on the x-axis. The other parenthesis, this one's easy. X minus 6 equals 0. Move the 6 over. And the other x-intercept for this quadratic function is at positive 6. All right, let's try that last one. Actually, let's wait on this one. Here's a bigger smiley face. We'll do this one on our next day in class.